we should get an answer. But it's all schmunched together. And schmunched together is not good. So we want unschmunched. The way we do that is we go to Format, we go to Column, we click Column, and then we go to Auto Fit Selection. And we click Auto Fit Selection. What that'll do is it'll make everything fit so that the writing isn't smunched up. So now we're doing pretty well, except everything is a little bit purple. We can click in any cell we want, any other cell, or any cell at all, and it'll make this purple go away. So I'm going to click up here, and now all the purple has gone away. Now let's look at these, what we have line by line. The first line I made red, shouldn't be red, but I made it red so we could see what line we're talking about. In the first line, it tells us the mean for each of the two clinics. So for Clinic A, it's 2.78 for the sample mean. And for Clinic B, we have 3.36. So their sample means differ. But that doesn't surprise us. We would expect the sample means to differ, even if they came from the same population. So that's not a big surprise. The next line is our variance. And we selected variance with samples with equal variances. Now, these look like the variances differ quite a bit. One is almost 4 times higher than the other. But anytime we take two samples, even if they're from the same population, we're likely to get different variances, just like we're likely to get different sample means. So this isn't too surprising, but 4 times is a little worrisome. We'll talk about that a little bit later. Observations, it tells me that we have 6 observations for Clinic A. And it's real important that you check these. Make sure that you really do have 6, because it's easy to make a mistake and not grab all the data you wanted to grab. So in this case, we do have 6 observations. For Clinic B, we do have 7 observations. Note that there's not an equal number of subjects in each group, but that's all right. The pooled variance is the variance, it's kind of the average of the variances for Clinic A and Clinic B. It's sort of that. That's probably the best way to think of it. The hypothesized mean difference, in this class we always use 0. So that'll always say 0. It's possible, although we'll never use it in this class, to say does it differ by 5 or more? Or does it differ by 3 or more? Or 2 or more? So it's possible to specify some difference other than 0. But in this class, we'll always use 0. The next column, getting ahead of myself. The next column is the degrees of freedom. And in this case, we have 11 degrees of freedom. Because it's a total number of subjects, we have 13 subjects minus the number of groups. And we have 2 groups. So 13 minus 2 is 11. We don't even have to calculate that. Excel has done it for us. Next, the t-stat is what your book calls t-comp. This is a computed t-value, or the t-statistic. So in this case, our t-statistic, our t-comp, is negative 1.7770. The next row tells us the probability of getting a t-stat that differs that much from 0 if these two samples really did come from the same population, and if we were doing a one-tailed test. But we're not doing a one-tailed test, so we can skip that. The next is a critical t for a one-tailed test, and we're not doing a one-tailed test, so we can skip that. The next is our p-value, and this we will use. This is our p-value for a two-tailed test. And notice it's just double what it was for a one-tailed test. And so in this case, it's 0.1032 once I round it off. And we'll use that when we're doing our 7 steps. The next value is the one we're after now, which is our t-critical, our two-tailed test. So that, our t-critical value is 2.2010 if I round it. 2.20098 would round to 2.2010. So let's go back to our 7 steps. Let's take a look at where we are. Here we're looking for our rejection rule. We're saying reject HO if the absolute value of the T-comp is greater than or equal to. And so looking at our output, we see that that's that bottom row. And so we'll put 2.2010. So let's put that in our rejection rule. So reject HO if the absolute value of T-comp is greater than or equal to 2.2010. And you can see where I've filled those in our picture. So if we end up getting a T-comp that goes in either of those tails, we get to reject our null hypothesis, which is what we want to do. If we don't get it there, then we've failed to reject. And that's not good. Let's take a look at what our T-stat was. Our T-stat was negative 1.770. Well, let's enter that into our step then. So our computation and test statistic, our T-comp, is negative 1.770. The absolute value of negative 1.770 is just 1.770. Now we can go back to our rejection rule and see what it says to do. It says to reject HO if the absolute value of T-comp, which we now know is 1.77, if that's greater than 2.20, is not greater. So this says we could reject it if it was greater, but it's not. So here we must fail to reject. The picture down below kind of shows you what this would look like. Our negative 1.770 is closer to 0 than our negative 2.2010. So our test statistic did not end up in either of the rejection regions. So here we fail to reject. So our decision is fail to reject HO. Now comes the most difficult part of the whole thing probably for most students, and that's to write a good APA conclusion. And a good APA conclusion always starts the same way whether or not you reject the HO. It always starts out by stating your alpha. So here we would say 7, conclusion, at an alpha level of 0.05. They always start out that way. Now the next part of the conclusion does differ by whether we reject or fail to reject. Let's assume that we had rejected HO. We don't, but I just want to do this as an example. So if we had rejected HO, our decision would have been reject HO, and our conclusion would be at an alpha level of 0.05, the mean forced expiratory volume for 1 second for patients with coronary artery disease is significantly higher in Clinic B than in Clinic A. But how would we know B than A? Well, we can just look at our data and we can see that the Clinic B sample mean is higher. And if it was significant, then it would have meant that it was significantly higher. But it wasn't significant, so we'll have to go and look at it this way. We really failed to reject. So what we have to say is at an alpha level of 0.05, there is insufficient evidence to conclude that there is a difference between Clinic A versus Clinic B in the means of the forced expiratory volume for 1 second for patients with coronary heart disease. Wow, that's a mouthful. And that's only 2/3 of that's 2 of the 3 parts we need for a conclusion.